Okay, guys, chapter 4 is chemical bonding. It's a very important chapter, and it's really considered the backbone of chemistry because it goes through the whole type of bonding, and it goes through type of the shape of the molecule and all the uh, chemical properties and physical properties of uh, the bonding themselves. So it's not that very comprehensive, but it's very good to know this chapter because that will be covering the topics inside the final exam ACS as well as in our quiz and exam. So when I say chemical bonding, I mean for our uh, interest, the major one, we look into two types of bonding we are dealing with. Those type, the first type here called the first type we call the it has always the metal here will be ionic bonding or ionic chemical compound. When I say bonding means so ionic bonding, which are ionic compounds, and then the second one we call this one here covalent bonding. So we have two. We have two types of bonding we are dealing with. Those are chemical bonding. We'll start with we're looking at the ionic bonding here. So everybody has this. Okay, so you have this and you have this. So let's look at the ionic bonding first. Ionic bonding always will be dealing with a combination of a metal. It's a combination of a metal with non-metal or non-metals if you have more than one. Okay? For example, I have potassium here. I have chloride here. So I can combine those together here. I can produce ionic compound KCl. So the ionic compound condition or or requirement is you have the presence of what of a metal. So it has a requirement here, which is metal presence. So that's if you don't have a metal presence, then you are dealing with what covalent bonding. You are dealing with covalent bonding. So I am having here potassium and added the chloride to it. I got potassium chloride. So we'll name those later on, but at least we get this one here. So what's happened to this? It turns out to be, can I take this one out? So if I put those together here, potassium, what is the electron configuration of potassium? You remember that? No? We went through that together, correct? SBDF, SBDF, all those. So how much is potassium? How many, uh, not valence, how many atomic, how many electrons we have? Yes. In the top is 19, correct? In the nuclear chemistry chapter, we have flipped atomic mass at the top and atomic number at the bottom, correct? Here in the normal thing in the periodic table, they put the atomic number. This is atomic number. And the atomic mass, how much? Close to 40, correct? 39.2. And this is atomic mass. But because we are dealing with the chemical reaction, we are not interested in the atomic mass. We are dealing with atomic number, with the number of the electrons. So we have to accommodate 19. So then I will say 19, correct? And this is in the fourth period. So let's write it here. This is in the fourth period. Then you know that's the last orbital has to be in the fourth period. In the last outermost means the number of the period will give you the hint. That's the, because those 7 periods from left to right, meaning 7 what? 7 orbitals. So it give you 7 orbitals you have. So fourth period, and group number what? Group number 1. So first group. So the first group here will give you number of VEs, valence electrons, which is 1. So potassium then, with the 19, will be looking like this. 1s2, 2s2, 2b6, 3s2, 3b6, correct? So how much we have now? 18, correct? Now one more left will be what? 4s1. So if I look at the whole thing here, that's really a configuration of what? I go potassium all the way to the end of the period, number 4. Krypton, then I go one up. This is argon, correct? This is really argon with 18 and 4s1. So this is argon and 4s1, correct? We're gonna keep this one here to know, and then we'll go for the chlorine, see what's going on with the chlorine. So let's go and look at, yeah, so I will wait. So everybody has this? Okay, so let's look at the chlorine itself. Let's look at the chlorine itself. So let me take this one out. Can I take it out? Everybody has it? Okay, let's take it out. Now we are looking at the chlorine. Remember, potassium is the metal, chlorine is non-metal. This is ionic. So let's look at the chlorine. We are looking at the atomic number of chlorine is 17. And the atomic mass, we are not interested, 35.5. However, we are interested to know what group and what period. So period, what period is in? 1, 2, yeah, third, correct. That's the third one. How about group? What group it's in? It says 17, but when I say 17, always after the 12 here, after 12, correct, 13, always minus this one here by 10. So 13 is what? 13 is 3a. 14 minus 10, 4a. 15, 10 minus 5a. 16 minus 10, 6a. 17 is group number 16, correct? And this is 16 minus 10, correct? This is 6a. Why am this 16? No, 17. Sorry, 17. It is 17. Sorry about this. So 17 here, and this is 17, and this is why I'm looking at this, this is an old A and B, it means old designation of periodic table, which is by far is good to determine the valence electron. So 7A will give me, that's the group, correct? So group 7A, meaning I have 7 VEs. How many? 7 VEs. 7 valence electrons, 7 VEs. So, and I have to accommodate how many? 17. So, and this is third group. So let's start together. Let's start together here. Let's start 1s2. That's the first orbital. 2s2, 2p6. That's the second orbital. 3s2, 3p. How much left? That's 10. 12. How much left? 5. And we said it has to be what? So the VEs are 7 electrons, 2 plus 5. And those VE 7 residing on 3s and the 3p. Those are the valence electrons. Those are the VEs. Correct? Now with this one here, what will be? I go all the way to the end of the group 3. That's argon. In the top of it, what? 10. Neon. Neon is 10. And 3s2, 3p5. That's the valence electrons here. Okay, guys? Everybody's following? Everybody's following? So now, what's happened in all this one here? What will happen? Can I take this one out? Okay, let's take this one out and look. Let's take this one out. We have potassium, correct? And we said potassium came out to be argon 18 and 4s1, correct? This potassium will give away 1 electron because it has 1 valence electron. It will give 1 electron. By doing this, potassium will be positive. And the potassium positive will be just argon, correct? The 4s is gone, correct? The 1 electron here, if you look at this, the one here is, so potassium is here, correct? So the potassium plus is argon electron configuration. Now if you look at the chlorine here, the chlorine came out to be, that was neon, correct? And we said we have 3s2, 3p5. And this one here will take this electron in, and it will be how much? Will be 18, correct? Everything's following? Will be chlorine minus, because it takes 1 negative here. So this one here will be, this one 17, 18 will be argon, which is, if you wish, that will be neon 3s2, 3b6. Started with this, you add 1 electron to the 5, 6, and that's really nothing else than 18 electrons, that's argon. So you can see 1 is giving away, donating, B is metal. Metal is donating these, and the non-metal is accepting VEs. Okay, guys? So you can see by donating, always they want to reach what? They want to reach the most stable electron configuration, which is the noble gas. Noble gas. So they want to always reach noble gas electron configuration. Are you following me here? So they want to always reach the noble gas configuration. So this is type of what we call it octet rule, with what? Noble gas as always, noble gas or noble gas group is 18 minus 10 is 8A. So how many valence electrons? 8 VEs. So this is what we have, octet rule. Octet rule is octet rule. So the octet rule is telling us when the metal combines itself with the non-metal, the metal tends to give away its valence electron and reach noble gas octet, noble gas electron configuration, which has 8 valence electrons, and the chlorine is accepting those valence electrons and reaching out the most stable. Because why is octet? Because that's the most 8A here, noble gas group, or 18 is the most stable group in the whole periodic table of the elements. So those are the only elements are very, very stable at all in the whole, very, very stable, chemically really inert. So, and this is what we call octet rule. So what is octet rule? Octet rule, when the metal, correct, making a ionic compound tends to give away its valence electrons and reaching electron configuration of noble gas with 8 electrons, and the nonmetals accepting those valence electrons, reaching the electron configuration of noble gas of what? Of 8. Octet means what? 8. And that's what, why they are doing this? Well, they want to reach to the stage of a very stable bonding. So the stable bonding, it has to have both cation and anion reaching noble gas. So we have a couple minutes. Then I'll tell you here. Can I take one out? Everybody has it? Everybody has it? Okay, good. Now, we have to introduce ourselves, but don't start laughing at me, because that was a long time I put this one here, and I was laughing, I was cracking myself up with other professors. I put here it is, potassium here, because it has a positive called cation, and the chlorine is called anion, negative, means negative or negatively charged atom, correct? And this is positively charged atom. Now, the multiple choice about cation. One of the multiples multiple choice, I mean, I said is cation. One of the choices said negatively charged atom, positively charged atom. Number 3, cation is cat plus ion. Number 4, none of the above. So, 4 multiple choices. What is cation? Well, negatively charged atom, positively charged atom. Number 4, cation is cat plus ion. Cat plus ion. And number 4, none of the above. What's the answer? Cat plus ion? That's what cracked us as a professor. I showed them the lot of students said cation is cat plus iron. No, has nothing to do with the animal cat. Are you following me here? Don't, if you get something like this in the, I did not put it for a long time, but I did put this one here on purpose. See, students really aware what the difference between cation and anion. A cation is any atom that is positively charged, and the anion is any atom that's negatively charged. Has nothing. The cation has nothing to do with the cat. Okay, just don't. We were cracking up, all me and all my French professors. Showed them a lot of, over the majority, 60% of the class took as a cat plus iron. Anyway, so that's, they have not done their we have 4 minutes. 4 minutes, guys. Cool yourself down. Cool yourself down. Now, I would like to let you know about the the physical properties of ionic compound. This is very important topic here. Let me yeah, we have still 4 minutes, guys. So cool yourself down. Just cool yourself down. Yep. So physical properties of ionic compound. Well, the most striking about the physical properties of ionic compounds or ionic bonding. Somebody will tell me, we did this one before. They have a metal. What you can expect from the metal? Most of them what? What we can, we talked about this before, correct? So they are, first, the most important stuff, they are conducting electricity. And they are polar. Polar, they are mean what? Soluble in H2O. We'll talk about polarity has to do with the electronegativity. We'll come in this chapter. It has soluble in H2O. They are soluble in H2O. They conduct electricity. And number 3, they have higher boiling point temperature. So if you wanna melt them, you need really an oven to melt them. Most of them, they have very high melting point. So number 4, most of them are colorful. So you can see, as we will see, the opposite. Covalent compounds, they are not colored. They are not colored. They are white crystals or just white crystals. All they have no color. I will stop here. This is the most important features of the ionic compound, and then we'll come and look at the covalent compound. Thank you very much.